I think it's good to consider at least one other digestive peptide, the gastric inhibitory polypeptide, GIP.
Okay.
It's my general picture of the organism, for example, analogous to the sympathetic nervous system and the parasympathetic nervous system.
Right.
The day and the night sides of the nervous system.
Right.
Everywhere you look, you can see this sort of a polar opposition in two kinds of function. One is mobilizing, the other is demobilizing and relaxing.
Okay, that's the parasympathetics is the relaxing, and the mobilizing is the sympathetic.
And when the organism is young and healthy, that opposition works very nicely for night and day action and rest cycling. And in the digestive system, when you eat fats and proteins, you secrete the cholecystokinin. When you eat sugar, you secrete the GIP, which is also called the insulinotropic hormone, because it calms down, stops your acid digestion, because you don't need acid to handle sugar, but it activates the insulin so that you handle the sugar. And when you look at the effect in the brain, CCK activates the corticotropic release hormone, which turns on anxiety and stress, and the pituitary ACTH, which turns on the adrenals to handle stress.
Okay.
And the gastrointestinal gastric inhibitory peptide responding to glucose has pretty much the opposite effects. And in the hippocampus, for example, which is a part of the brain that's expanded by opportunity and learning, and shrunken by stress, the insulinotropic hormone responding to sugar also has receptors in the hippocampus that stimulates the birth of new cells. So learning and stimulating experience and eating sugar has the same
go hand in hand, huh?
Yeah, the same effects in your brain. Eating fat and protein, surprisingly, turn on anxiety and stress.
Even protein, huh?
Well, that tends to lower your blood sugar because it also stimulates insulin.
Got it.
And lowering the blood sugar turns on stress.
Okay.